Do you know the difference between open access and OASIS in VLSI? Do you know the difference of GDS2 and OASIS in physical design? If you are a new designer, do you know what things you should check before you completely move on to OASIS? Stay tuned till the end of the video to know all the answers. Hey guys, welcome back. In today's episode, we are going to discuss the OASIS file format. So here is the menu for today. First, we will introduce you to the concept of the OASIS file. What is a OASIS file? What is the background, etc. Next, what we will cover is the comparison. Why the OASIS is better than the GDS format, that is GDS2 file. Next, we will do a comparison of the compression algorithm of GDS versus the OASIS. Now, the compression algorithm helps for the different layer elements that exist in the file, that means the binary file, to have a less area in the hard disk. Next, we will talk about why the OASIS is the choice of the present layout designers. Next, we will give some cautionary points that if you want to move from GDS2 to OASIS, what points you should be checking. That means, what are the prerequisites? What is open access? Then, whenever we talk about OASIS, the first two letter OA that comes into our head. And also we have a term called open access. So we will talk about open access also in this context. Next, we will do a infographics to understand the OA and the OASIS comparison better. Finally, we'll do our conclusion of the entire discussion. So here is the menu for today. Without any further delay, let's begin. Introduction. OASIS stands for Open Artwork System Interchange Standard. So this is the abbreviation of the OASIS. OASIS is not a word. It's not the thing that you can see as a mirage, but rather this is an abbreviation which is containing the entire string, that is Open Artwork System Interchange Standard. Next, OASIS is very similar to GDS2 in function and purpose. So, the target goal of the usage of OASIS and GDS2 are very same. OASIS is a new electronic pattern of layout language created as a commercial successor of the GDS. So now, what is the layout language? The layout is of a cheap layout, right? That you have different standard cell IPs, you will have macros, all of them. However, this is your front end where you are using. By front end, I mean that this is not the front end design. This is the front end of the software, what you are using. And the back end of the software, layout software. This file is a set of binary codes. So that is called the layout language, etc. It was developed to solve the problem of large GDS2 files that were unable to keep up with the growth of the integrated circuit layout complexity. We are moving down below the 10 nanometer today, and the OASIS has a better compression algorithm as compared to GDS2. Hence, whenever we are exporting our layout into the binary files, that can go to the foundry, right, as a mask. So that format is GDS, and it was causing a lot of area in the hard disk because their multi-million gate designs are today done in our chip design area, and those are not very small files, very large files. And GDS2 was consuming a lot of hard disk, and the OASIS is developed with a better compression algorithm so that it takes less area in your hard disk. OASIS is a binary file format developed by SEMI. So SEMI is an organization. You can go ahead and search in Google about SEMI for the expression of electronic patterns in the integrated circuit design and architecture. Why we call it a binary file? Because you opening up the OASIS file in a text editor, only binary characters you will see. You will not see any human readable character. That is meaning of the binary file. However, if you are opening the OASIS file with the respective layout software, you will see the layout. It defines the code of geometric shapes, their properties, organization into cells, and relative placement. So these are things what you expect from a layout software. That means where you design the layout or you process the layout, whatever you are doing with the layout. Now we come to the point where we talk about more detail of the OASIS. So OASIS includes 25 types of trapezoid, variable length, numeric format for coordinates, and gzip-like compression. So in the Linux series, we have talked about the different compression mechanism of gzip, tar, and etc. You can go ahead and find the respective episode from the playlist, and you can have a good knowledge travel on this. Let's come back to OASIS, gzip-like compression algorithm to reduce the data size. So this this gzip like compression is inbuilt, that is the inherent or residual, whatever you can say. It is with the file format itself. It is not added as an extra command of gzip, and was adopted by the integrated circuit design, equipment, photomask, fabless and third-party intellectual IP manufacturing companies. So in case you do not know about the different companies that exist in the VLSI ecosystem, we have an episode on the VLSI ecosystem. You can find it from the channel videos, and I think this was the first video we published. Also, I am providing the link in the video description. So all these houses, all these type of various VLSI company houses, they can use OASIS, and obviously all of them have to use because of the interoperability. That means whenever something is going from one design house to another, or it is coming from foundry to the design house, whatever, once you watch that episode, you will better understand what is the exchange between the different type of companies inside the VLSI ecosystem. So here we are done with our introduction. Let's move on to the next slide. Why OASIS is better than GDS? So you have already come across the point. Now let's elaborate the thing and see in a much more detailed manner. With advancement in process technology, IC layout designers can deliver more functionality in the same chip area. We are having more complex design today. Now AMS, that is the analog and mixed signal chips, are there, where you have both the blocks for the analog part and the digital part, and they are working with each other together to give the required output. Now these will be very, very high file size in terms of the physical hard disk. That is the point where the OASIS is coming into picture. However, this leads to the large file size with full chip GDS files layout that you can be hundreds of gigabytes or even terabytes in size. So why we talk about full chip? Full chip means we can have full chip, we can have sub chip. Sub chip means we just design the layout of a part of a chip or the chip as a whole. So at that time, the layout consisting of macros, consisting of analog block, consisting of digital blocks, and all of them what you want to get the required output. That ensemble is huge size, terabytes. Okay, so earlier even your desktop PC or laptop PC had maybe 500 GB, 1 TB, right? Now you can have 4 TB, 8 TB of hard disk. However, as the area of the hard disk is increasing with time, we also have the respective layout design files going larger. Now you will say that, okay, I have a large hard disk file and why I need the compression at all? Because it is not you alone who is designing at your own home PC which no one access. Rather, in a VLSI company, multiple peoples are there who are sharing the same disk space, and you have to share that same disk space because there will be a lot of dependency file that you have to access. Now at that situation, when 10 people are using a hard disk, maybe 10 TB or 20 TB hard disk, right? This layout file could cause the crunch in the disk space. So this is the scenario. Let's move on to the next point. This can result in longer loading times of EDA tools, which can frustrate the user and impact the tape-out schedules. This longer loading time means whenever a designer coming into office and that day he or she is working, before the actual work start, the time will be elapsed and will be wasted because of the large file size. So maybe the layout is taking time of 45 minutes to load. I'm just guessing. That time that particular 45 minutes of work energy of that particular employee will be lost. That is a big concern because today we need to be very much faster in delivering the layout solution, whatever we are doing as a VLSI engineer. And this will impact the tape out schedule because once you approach towards the tape out, the ensembles, that means the macros, analog block, digital block, whatever are there which are getting assembled as a final layout. So the layout will grow from a smaller unit, and when you assemble all the smaller units, you get a bigger area, right? So that bigger area is going for the tape out, and that will take much more loading time. And that's why just at the 11th hour of the tape out, you will get frustrated because of the loading time of such big layouts. Zipping GDS layouts may reduce the file size, but it can increase the loading time. So this is the challenge. One is the challenge of saving the file in the hard disk. Another is the loading time in the designing software. That means layout designing software, whether it is an implementation software or it is maybe a analog chip design layout software, whatever software it is. But there are two sides. One, the disk crunch, and there is another thing which is the loading time. A better solution to switch to the OASIS format, which is accepted by the major of the foundries. Today, most of the foundries support the OASIS file format, and it can reduce both file size and loading time. So there are two aspects. One is the disk space, another is the loading time in the RAM of the respective machine that you are using. And you know, right, when you are working in the VLSI industry, you are using a LSF or UG kind of machine. In case you do not know anything about that, there is one particular episode or multiple episode there in the Linux series. Go ahead and find the respective episode there. Hey, we use Linux at all. I think this is the title of the video where I have already explained why the importance of the Linux is there in the VLSI industry. Now let's come back to this point, and what happens that the file is loaded on a machine, but that machine is not the physical machine that you are using. It's a remote machine that you have invoked to the LSF or the UG command, and that machine having a large RAM and all these things, these machines are not in an abundant quantity in any design house. So they will be in a very restricted quantity. When you are booking and using a machine dedicatedly with the large RAM and the disk area, so you are actually at that time you are depriving others to use that particular machine. And that point, when all these crucial things are ticking on your head and you are towards the tape out, the two things will bother you. One is the disk size, the common disk space which you are sharing with other co-designers, and the loading time in the LSF or the UG machine. So that will make your life hell. So just to save you out of that hell, the OASIS jumps into the picture and give you the solution. So here the OASIS, why it is better than GDS, we have talked about. Let's move on to the next slide. Now we will compare the compression algorithm between the GDS and OASIS. OASIS data uses variable byte lengths to represent the numerical values, while GDS format uses fixed byte lengths. So it's inside the algorithm to save the disk space, nothing else. OASIS can recognize complex patterns and store them as repetition, and hence it reduces the file size. So this is the internal method of the OASIS that is better than GDS. OASIS C blocks. C blocks are the basic binary blocks in the OASIS file. Features applies internal gzip compression. So these blocks, each unit block can apply the internal compression algorithm to individual cells within a layout. This enables, that is enabling parallelized unzipping and faster loading time. So this means that when you are loading the file, so it's not a two-step process. It's not first you are unzipping it and then opening and loading the file. Rather than it is on the go. When you load the file, the things are internally unzipped and loaded into the RAM of the layout designing software. Picked mode OASIS layout contain internal lookup table, which improves loading time efficiency by allowing the reader to parallelize the loading of the layout. Word of caution: zipping an OASIS layout, as it only provides the minimal file size. Okay, so it can have the disk space problem reducing. That means it can help out in the disk space crunch reductions and increases the loading time, since the tools must uncompress the file twice. That means it becomes a two-step process, that it uncompress the file and then it have to go through this internal process of the file where the internal C blocks are unzipped and loaded. So it can cause rather much loading time than a regular OASIS. So this is a word of caution when you are using the OASIS. OASIS itself is enabled with the C block gzip compression internally, so that you do not need to do the compression externally. While in some cases, zipping an uncompressed OASIS layout may reduce file sizes more than using C block. In some cases, it may happen. You might be doing a subchip or maybe a block level OASIS. So in that case, you can use that. Layout readers cannot load a zipped OASIS layout in parallel without first unzipping the file, leading to increased loading time. Generally, what happens in GDS2 file, to save the disk space, we zip it or tar it, whatever we are doing. We are using a compression algorithm, and if we do the same thing with the OASIS, we'll be facing only problem, will not get a solution. The recommended approach is to use the C blocks, which offer internal compression within the file and can be uncompressed in parallel, providing significant loading time. So it is advisable at the final. So don't try to apply the compression, that means the external compression, tar, zip, rar, etc. with the OASIS while you are working as a designer and opening on a daily basis the file. You can do whatever the compression when you are transferring the file. That means you are transferring the file from one maybe IP design house towards the design house, that you can do for transferring of the file. Maybe you are writing them on a DVD and shipping it. In that case, you can do it. But when you working on a day-to-day basis from the hard disk, it is advisable that you use the internal compression method of OASIS and don't try to do the external compression. That means zip, tar, rar, etc. Don't do anything. So here we are done talking about the compression comparison between GDS and OASIS. Let's move on to the next slide. Why the OASIS is the choice of the present. Nowadays, we have multiple type of layout engineers. Maybe a mixed signal one, that means where we have the analog and the digital. Or it might be a solely a digital where we have multi-million gate design. All these layout designers, why they are preferring OASIS today? OASIS is a system that reduces the size of database in optimizing file structure, suppressing redundancies and compact values. It reduces the size of the geometric description by reducing the number of coordinates needed to describe a polygon and reducing the size of each individual coordinate. So the internal things, in case you are not a layout engineer or you have not seen the layouts, it will be very difficult for you to understand these points because we have to yet create an series on layout. Otherwise, I could have told you that go ahead and watch that episode. So at this point, we are still, the layout episodes are in pipeline, so wait for those. It also overcomes the limited precision of numerical values by storing them with variable length encoding. OASIS optimizes the layers, data type values, and geometric repetitions of design, and it allows for the hierarchical structure of a chip. So all these points are preferred by the layout designer today. Whether that layout designer is designing a SoC of multi-million gate or doing a AMS chip, whatever that person is doing. OASIS also enable compression of some blocks in a file using gzip-like format. Next, an OASIS file between 5 and 20 times smaller than a encoded in GDS2. So OASIS file is 20 times smaller. Maybe it starts from the 5 times and go up to the 20 times smaller. So 5x to 20x smaller size of OASIS file as compared to GDS2. That's why all these points signifies why the OASIS format is a choice of the layout designer today. We're done discussing this slide. Let's move on to the next slide. Checks before you switch to the OASIS format. I consider that you are a layout designer or you are maybe heading towards a layout engineering post. So what things you should be checking? What are the prerequisite or the checklist that you must look before you leap towards the OASIS? Most major foundries and commercial EDA tools now support OASIS. However, you must double check at this point on your own. So you must check whether your tool is supporting, your PDK has OASIS, all these points. If you work with a smaller foundry or use internal layout tools, it is recommended you check both of them the support of the OASIS format. That means the PDK or the TK you are using and the internal layout tools. In case you are using an in-house layout tool that is a proprietary to you only, in that case you must double check the compatibility of the OASIS in all the cases, in the entire chain of the VLSI design from start to finish. For the layouts only, I'm not talking about the synthesis on all those tools. Additionally, if you use the IP from a third-party supplier, it's important to ensure they can provide the IP in OASIS format or have a discussion with them about changing the format without your contract issues. This third point is for the designers who are working in a design company and you are borrowing some of the IPs from external IP design companies. That time when you are signing the contract, you must check whether they are supplying OASIS format that doesn't violate the contract that you are signing. So this must be very important. So you must take your sales guys who are doing this contract on all these things in confidence. As a designer, you must talk with the sales guys who are doing the monetary transaction and the contracts and all those things. So you must also have a discussion with them that whenever you're doing the checking, right, that we need all these things from that particular vendor, IP vendor, we must provide the OASIS and we do not violate any terms and conditions there. And I think now this is a okay point to talk because most of the layout tools are now having the OASIS compatibility. This we are done all these points. Let's move on to the next slide. What is open access then? We have so far talked about the OASIS, and sometimes we find a similarity of the OA and the OASIS. Now, what is the open access then? We came about the OASIS. I intentionally introduced this particular thing to get you out of any confusion. Open access is a language-based system information in IC design and manufacturing. It consists a set of C++ functions that operate on a hierarchical set of definitions known as Open Access API. Just wait for some time. In upcoming slide, we have infographics to understand all these points that we are talking about. Open access offers many advantages such as a freely provided reference database implementation, supports the API and tested and production level quality of the performance. So the open access is a kind of API, that is the application programming interface in the layout tool. What it does, what it takes as in, what it gives as out, we will see in the info. The reference database is highly structured, modular and open source, making it accessible to the public and able to be used by the commercial application within IC design and manufacture flows. The goal of the open access is to achieve industry acceptance of the API rather than standardizing use of the reference of the database. So these are very highly technical terms that you get here. Now let's move to the simple explanation, more simpler explanation with the infographic. Here is the infographics. This will make your life easy to understand the OA and the OASIS, how they are related. You have to wait till the end till I fill up the entire infographics in this entire slide. First, we have our designer, that is you, who is designing, and you have your layout mask, that is layout and optical proximity correction, etc. You are doing all this data with you, and these will go to the open access API that is present in your layout tool. Now what else goes to the open access API? We have the PPA, that is power performance area, timing target, design intent, all these things, that is the goal of the design that you are doing, which are fed through our EDA software. And that things also go to the open access API. Next, we have the foundry side data, that means the equipment characteristics, the characteristics of the fabrication equipments, DFM, design for manufacturability, DRC, design rule check, and we have the variability today. All this data that comes from the foundry, that will also go towards the open access API, because this open access API interprets all these things to give the output. Okay, let's wait for the suspense, what output it gives. More to go, fab constraints are there. That means there are some constraints provided by the fabrication house. And like that, what we have, lithography details, DFM, mask, all these details. And those also being fed to the API. Now, as a designer, apart from all these details, you have your design database, right? What you have made ready after front end and after back end, multiple steps in the back end. So there you have the design database, right? When all of these things are together, we put into the open access API of your layout tool, it can give the output as GDS2, or it can give the output as OASIS. Now you can understand the, you can say correlation, you can say difference of the open access and the OASIS. So open access is an API, that is the application programming interface in your layout tool, that does take all these inputs, right, and give a GDS2 or OASIS as a output. So this is the infographics to understand. When you face your actual layout tool, you may find this may be written, maybe a script talking about all these details, right? All these details there may be in a tickle script, and it may be getting auto source you without even you notice. But in case you have this slide or the snapshot of this slide with you, that time you can backtrace, check that all these things are going to the layout software to some or more of the file, and that open access API actually receives all these informations and translate them into either GDS2 or to the OASIS format. So here is the relation of OA and OASIS we have talked about, and now the things are clear about the similarity and difference. There is actually no similarity, it's actually different things of the OA and OASIS, although there is a similarity in the text, that is OA and OASIS, so you don't get confused about OA and OASIS. Conclusion. We have talked about so much, let's conclude what we have discussed. The OASIS format has limitations and can add potential sources of error during the transition from GDS. Limitation we have already talked about, that all those dependencies, that means all of your houses, design house, IP house, foundry, all have to be compatible with the OASIS. Different EDA vendors offers various methods of generating OASIS files, and there is still some resistance to the new format. The people are generally laid back. They want to stick to the comfort zone of the file format being used. If you are watching this video right now, you should not be in that laid back mode. You should be on your feet for the change for the OASIS format. Check everything that we have talked about throughout the episode, and you should go and be courageous to use the OASIS format. However, it is believed that existing disk and RAM capabilities is not a better deal when changing to OASIS. When you are changing a machine in your LSF, it costs a lot of dollars. So rather than if you are having a smarter format OASIS, I think that is better. The complexity of OASIS means that there are more possible errors than GDS2, and database in the new format requires careful validation. This validation, that is the QC/QA, quality check and quality analysis of the layout, should be done properly when you are using. So that means when you are you are making a transition from GDS2 to the OASIS. To make sure everything is fine, because once the silicon is made, the design is on silicon, you cannot change it. It's not a software that you can release a patch. So that is why the careful validation should be done before the mask go to the foundry or fabrication on silicon. Despite this, the same detailed checking process built confidence in GDS2, and the arrival of OASIS format reader software is necessary for building a platform for the new standard. More of the softwares are now leaning towards the OASIS format using, the open access API, right? That actually helps the layout designer and makes the life easy for the layout designer, whether the layout designer is from the AMS or the digital or the analog, any one of them makes the life easier. So we are done here with the conclusion. Let's move on to the next slide. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below, and bye for today.